Here's a good question where you're trying to match equations of parabolas with their graph. First thing that I would do to separate things out is look for x squared ones versus y squared. Because I know x squared go like this or like that, and y squared go like this or like that. So if I see x squared here, this one here, I know it has to be an up or a down one. So it can't be those three. The only choices are D, E, and F. So that's narrowing things down for me. I also know that this one is of that form x squared equals 4py, and since there's nothing attached onto the x here, like x minus h squared equals 4py minus k, so since there's no h or a k value listed there, we assume them to be 0. And so this particular graph would be an up-down one, but it also would have its vertex right on the origin. Since this first value is positive, the vertex must be on the origin and it must open upward. So I need to find one that looks like that. It's not that one. Not that one. It has to be that one. So 1 is F. Okay, 2, similar thing. I have y squared equals 4px as one of the equations, or y minus k squared is equal to 4px minus h. Notice that this one is like this one. So it's either left or right, one of those two. Since this is negative, it has to be has to open left, and it has to be on the origin. Okay, here's one left. That's the only one that opens to the left and is on the origin. Okay, so we've got those two. Next two. This one is a y squared one, so it's down here. So the parabola either opens to the left or to the right. Since it's negative, it opens to the left. We've already used C off, right? So, well, these two also open to the left. So I've got to check more into this. So this one also has numbers beside here. It's written in this proper form. So the vertex for that one would be -4 and +2. So I need to find either this one or this one that has a vertex of -4 and 2. -4, 2 has to be that one. Has to be B. Now in looking down, this one is another one that opens to the left. It has to be a y squared one. So I look down, that's an x squared, no, x squared. Here's a y squared right there. This one, number 6, has to be A. Okay, now I just have to choose between 4 and 5. So number 4, it's an x squared one. So it's opening up or down. Since this is positive, it's up. So it's not that one. And also I have a vertex of -1 and 2. So the vertex is -1 and 2. So I've got A, I've got that one done already. I've got B, I got F, and I have C. So it's between these two. So my vertex is -1 and 2. -1, 2, it's not that one. -1, 2, there's a vertex right there. So this one has to be E. Therefore 5 is going to have to be D. If you wanted to determine what the vertex of that parabola would be, you could. So I could go 13x squared is equal to 8y plus 9. Divide both sides by 13, and maybe instead of dividing both these by 13, I'll just put 1/13 out front and have an 8y plus 9 inside there. But I know I can't have an 8 in there, so I'd go x squared equals, I'd factor an 8 out. So it'd be 8/13, and then y plus 9/8. So now I've got it in the right format. It looks like this. No number beside the x, so that the vertex value for that would be 0, and the vertex for this would be -9/8. So vertex of 0 and -9/8, just over 1. Yeah, it looks like it's this one. So that one has to be D. Hopefully that helps out in just sort of identifying some characteristics of the graphs from the equations.